Hello, this is Mrs. Scarple, and in this video I'm going to cover solving by completing the square. Remember, we use completing the square to write a quadratic in vertex form. So when we're completing a square, that's when we want to make a perfect square. Since this particular problem begins with x squared, I only need one perfect square. So that's going to have x squared in it. Keep in mind that the units of 4 are not going into the square. So I'm going to place those 4 units outside in a different rectangle. Now, if this is going to be a square, what has to be true is that the factor on each side of my square is the same. That means I need to split this -6 evenly. So that means I need to divide -6 by 2. So that's going to put a -3 and a -3 on each side, giving me -3x and -3x. And if I look at the original problem, that does give me the -6 that I need. Then I need to find my units. I do that by taking the -3 times the -3. The constant values give me my units. That is a +9. But that's more than what I need. So to find out what I'm going to have to subtract, I just take 4 and subtract those units, which is going to equal -5. So our vertex form for this problem is going to be x minus 3 squared subtract 5 equals 0. Now, unlike solving by factoring, I'm not going to keep this set equal to 0. What I'm going to do is I'm going to isolate this squared factor. So the x minus 3 squared I want to get by itself, and in order to do that, I need to add 5 to each side of my equation. So that leaves me x minus 3 squared equals 5. Now I can use inverse operations. So the inverse of taking something to the power of 2 is to find the square root of it. And if I do that on one side of my equation, I need to do it on the other side. So we're going to have x minus 3 equals, now this is what is important to remember. When I take the square root of a value, it has a positive value and a negative value. And for now, I'm going to leave it in its exact form of square root of 5. I'll show you in a little bit how I'm going to find the approximate answer. But I know that 5 is not a perfect square, so I'm going to leave it like this for now. Going back to the left side of my equation, I have x minus 3. What I want to do is add 3 to both sides. Now, that 3 is not inside of a square root. I cannot add it to the 5. Instead, what I'm going to do is write that x equals 3 plus or minus the square root of 5. And this is what we call the exact answer. To find the approximate answer, I'm going to enter 3 plus the square root of 5 in my calculator, just as it's written. 3 plus the square root of 5 is approximately 5.24. This notation that I have in front of the 5.24 means approximate. It tells me that I rounded my answer. The other one I need to find is 3 minus the square root of 5. So again, I'm going to enter that in the calculator just as it's written. And that is approximately 0.76. And these, we say, are the approximate answers. Let's take a look at another one. Here we have x squared minus 6x plus 7. So very similar to the previous one, except we have this plus 7. So we have a square. We know that x squared is going inside of this. And we also know that the units of 7 are going to be outside. From before, I know this is going to be x times x to get x squared. The other piece I know from before is that to divide the minus 6 evenly, I need a minus 3. So we have a negative 3x, another negative 3x, and now we have a total of 9 units, just like we did before. So I'm going to subtract those 9 units from my 7 to have a negative 2. So now my vertex form is x minus 3 squared minus 2 equals 0. Just like I did before, I'm going to isolate the squared factor by adding 2 to each side. So we have x minus 3 squared equals 2. To undo that power of 2, to undo the squaring, we take the square root of each side. So now we have x minus 3 equals plus or minus the square root of 2. Now to get x by itself, I add 3 to both sides, and my exact answer is x equals 3 plus or minus the square root of 2. If I want the approximations, I'm going to do 3 plus the square root of 2, which is approximately 4.41, or 3 minus the square root of 2 is approximately 1.59. And these are our solutions to this particular problem. Now, what if we need to complete the square and the leading coefficient isn't 1? Like we have here, we have a leading coefficient of 2. I see that the second value is divisible by 2, so I'm going to think of this as creating 2 perfect squares. So we're going to have 2 times a perfect square. And instead of writing it as 2 times, I'm going to write it as 2 squares. Just so you can see how that 8x gets split up. So each square is going to have an x squared in it. The units of 5, again, are going to go in its own special rectangle outside. The 8x has to be split over 1, 2, 3, 4 spaces. So that 8 divided by 4 is going to be a negative 2x. in each of those spaces. 4 times negative 2 gives me that negative x, or negative 8x, excuse me. So that means each side of each square is going to be x minus 2. So when it comes to units, I have 4 units and I have 4 units. That is a total of 8 units. So it's 8 that needs to be subtracted from the 5, not just 4. We need the total number of units in the 2 perfect squares, which is 8. And this will equal negative 3. So now, vertex form is going to be 2 times x minus 2 squared subtract 3 equals 0. Again, we're going to use inverse operations to solve. So inverse operations are using order of operations backwards. So I'm going to check to see if there's anything I can add or subtract first. I want to undo the minus 3, and I can do that by adding 3. So now I have 2 times x minus 2 squared equals 3. Now before I undo the squared, I actually have to undo the 2 times. Notice I said 2 times. If I'm undoing something that's being multiplied, I divide. So now I have x minus 2 squared equals 3 over 2, or 3 divided by 2, or 3 halves. Now I can take the square root of both sides, and I can write this as x, I want to use my black, x, did it again, x minus 2 equals plus or minus the square root of 3 over 2. To get x by itself, I'm going to add 2, and I have x equals 2 plus or minus the square root of 3 over 2. And again, I'm going to consider this to be my exact answer. To find the approximate answer, I'm going to do 2 plus the square root of 3 over 2, and I'm going to do 2 minus the square root of 3 over 2. And I'm going to enter it in my calculator just like it's written. So 2 plus the square root of 3 divided by 2 is approximately 3.22. Or 2 minus the square root of 3 divided by 2 is approximately 0.78. So the exact answer keeps it in the radical form. The approximate answer converts it to decimals. And this concludes the video on solving by completing the square.